Some trigonometric identities follow directly from the definitions of the 6 basic trigonometric functions. These basic identities consist of the reciprocal identities and the quotient identities. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. Tangent is defined as the ratio of sine to cosine values. Its reciprocal, cotangent, is the ratio of cosine to sine values. Here are the Pythagorean identities. Consider a unit circle with an angle, theta, drawn in standard position. The intersection point of the angle and the unit circle corresponds to coordinates where x is the cosine value, and y is the sine value. Examining the ratios of the 3 sides in the yellow right-angled triangle, we apply the Pythagorean theorem since it is a right-angled triangle. Substituting the cosine value for x and the sine value for y, we get cosine theta squared plus sine theta squared equals 1. Dividing both sides of the equation by the cosine squared yields 1 plus tangent theta squared equals secant theta squared. Similarly, dividing both sides of the equation by the sine squared results in cotangent theta squared plus 1 equals cosecant theta squared. These 3 formulas constitute the Pythagorean identities. Now, let's explore the cofunction identities. In the blue right-angled triangle, let's examine the sine, cosine, and tangent values for angles A and B. As evident, the sine of A and the cosine of B are identical, and angle B is the complementary angle to angle A. Therefore, sine theta equals cosine pi over 2 minus theta. Similarly, the cosine of A and the sine of B share the same value, and angle B is the complementary angle to angle A. Therefore, cosine theta equals sine pi over 2 minus theta. The tangent of A and the cotangent of B are also identical in value. Tangent theta equals cotangent pi over 2 minus theta. The same formulas apply to the cosecant and secant, which are the reciprocals of sine and cosine, respectively. As you may have noticed, the term co of cofunction identities directly signifies complements. Now, let's discuss the odd-even identities. When the angle theta and negative theta intersect the circle, their coordinates are x, y, and x, negative y, respectively. Examining the sine values in the blue right-angled triangle for angle theta and the red right-angled triangle for angle negative theta, we observe that the signs are opposite. Looking at the cosine values in the blue right-angled triangle for angle theta and the red right-angled triangle for angle negative theta, we notice that the signs are the same. Examining the tangent values in the blue right-angled triangle for angle theta and the red right-angled triangle for angle negative theta, we find that the signs are opposite. Therefore, we can conclude that the sine and tangent functions are odd functions, while the cosine function is an even function. These observations are known as the odd-even identities. The answer to the question presented in the video's initial thumbnail is here. See you next time.